Hello friends, welcome to Coding Garden with CJ. Welcome to Newb Quest, Auth from Scratch, Part 3. So we were live earlier, like 10 minutes ago, but I created another video so that they're a little bit separate. This video is going to be all about signing in. So the past few videos were about signing up. This is going to be about signing in. Say hello, Tony.
Hello.
Did you get some food in you?
I did. I had some, it's like Indian food in this like little easy microwave package.
Nice. I might actually eat one of those for dinner. A similar one.
It's like the 90-second meal thing.
This one? No, I forget what the brand is.
I don't know what the brand is. It's just like ready in 90 seconds.
Okay.
It's like it.
Like what?
I don't know.
Okay.
Let's
cool.
do this thing.
Yeah, let's do this. We're both feeling a little bit tired, but we're gonna do as much as we can. We're probably gonna go for like at least an hour. But yes, this is gonna be all about signing in. Let's talk about it. I have a nice little diagram and slideshow to show you. Okay, so the process, at least for sending the data to the server, is very similar to signing up. So the sign-in process, the client is going to make a post request to /signin with all of their information. So in this case, their email and their password. You could also be sending a username and a password. Once the server receives that information, they need to check to see, is there a user in the database with this email? If there is, we then need to compare the password that they sent us with the hash password in the database. So we used bcrypt to hash the password, and bcrypt actually has a built-in function for comparing two hashes to see if they were generated using the same input. So when you generate a hash with bcrypt, it actually looks different every time. So you can't tell by just comparing them exactly, but you can say, were these two hashes generated with the same input? So we basically take the password that the user sent to us for sign-in, and then compare it with the hash password in the database to see if they match. If they do match, then the user is valid, and we will actually sign them in. So we'll then respond and either like set a cookie. In our case, we're going to be responding with a Json Web Token that the client will store in the browser and then use that token in subsequent requests to basically show that they are that user that signed in. So the process: find the user by email address or username. In our case, we're going to be using username. Hash the password that the user entered. Compare that hash password to the hash password in the database. In this case, we actually don't hash the password that they enter. We use bcrypt.compareHash. We pass in what they sent us, and it will hash it and tell us if that input was the same thing that was used to generate the hash password that's in the database. And then you'll set a cookie or send back some sort of information that the client will then send in subsequent requests so that the server knows that that person was signed in or is signed in. Cool. So I have a nice little flow chart here. I guess before I get into that, hello Edgar, welcome back. Rohit, hello. Tony, Rohit says hello.
Hello.
And hello Chi, welcome back. So nice little flow chart here. So, and again, use your imaginations. In our case, we have a username instead of an email, but find the user by something. Were they found? No. Give them a not found error. Oh, so they're not found, and then just return some sort of login error, like unable to log in. Great. Were they found? Yes. We then compare the password that they sent us with the hashed password from the database. If it doesn't match, or if we determine that it was not the password that they signed up with, you return an error. Login error, cannot log in. If they did match, you then set a cookie or a session or return a JSON Web Token that can be sent in subsequent requests.
So, quick question.
Yes, sir.
So when Google, for example, is doing this, do they have some sort of like geo information that's associated with you as well? Like when you sign in, like for example, usually if I'm traveling in another city and I sign into my Google account, it says like there's something different about you.
They might send that information in the request. So, well, not send it in the request, but on the server side, you can actually detect what IP address that the request came from.
Mm-hmm.
And so, in the case of Google, like they store, like every time you log in, they store like the IP address that it came from, and typically you can take an IP address and turn that into a location. So, because they're such a large company and they have lots of people trying to log in to accounts that are not theirs all the time, they have lots of measures in place. So their backend logic basically says, and like has, and so their backend has all of your, or most of your previous logins stored somewhere so they can actually compare and say, okay, this incoming request is coming from an IP address that I don't recognize,
Okay.
or you haven't logged in before, and so I'm actually going to return an error and say, hey, maybe you have to do two-factor authentication and like verify with a text message or with your authenticator app on your phone, or it just says, or they send you an email that says, hey, we detected this login. If this wasn't you, let me know.
Okay.
But that's just more complex logic on the back end.
Okay.
Yeah. Yeah, and hello, Alka. Welcome back. He's mentioning Google tracks location and devices. Yeah, so if you're logging in from a new browser, from a new location, they will alert you that says, hey, something might be weird. He's even mentioning, like, if you log in incognito mode, that is technically a new browser, so you'll get a message that says, hey, someone logged in from a new browser. And it knows it knows that because they store a cookie. We haven't really talked about like what cookies are, but it's literally just something stored inside of your browser, and every time you make a request to a server, that cookie gets sent along with you. So if it's a cookie that Google has seen before, they know that you've logged in on this device before.
Okay.
Cool. Great questions. This is the flow. We're going to write the code that does it. What do I have here? Okay. Are you ready, Tony?
Yes.
Okay, let's go to my checklist. All right, login user with a post request to auth/login. So just like you have a post request to auth/sign up, it's going to be a post request to auth/login. So for now, we're going to minimize all of our client code. Let's close everything else that we had open, and then we're only going to have server-side code open. I have a feeling that we may not finish this. We only might get to a few checks, and we definitely aren't going to get to the front end for logging in just yet. But next weekend, hopefully, we'll talk and see if you're available. But
Okay.
yeah. Okay, server side, we need to create a new route that's a post route to auth/login. So that's going to go in here. If you remember, this is how we created a post route for auth/signup. So we're going to do a very similar thing right about here. So
Okay.
Tony, we're going to do a router.post because we're creating a route that responds to post requests.
Oh, you gotta give me the thing.
Oh, I got to give you control, definitely. I have a question in the chat. Will the session you're going to implement work on multiple devices? We're not going to be using cookies. We actually are going to be using tokens. And we're not going to be using sessions. It's purely going to be based on a token. So if you log in on multiple devices, you're still going to be yourself and have access to all of the same things. It may be a different token, but the token itself is stored on the client and then verified on every request. We'll talk about it more when we get to JSON Web Tokens. Yes, Jots, JWTs. So there won't be any sessions. It technically will work across devices because that you're going to have a different token on every device, and the server is going to be validating that token on every request. Okay, so it's a post request, and we want it to happen when the request is to /auth/login. So we invoke this. The first parameter is a string that is the route we want to run this request on. In this case, yes, what do you think?
Assuming it's our database.
Not our database. Let's take a quick break. For those of you that are watching this video, you weren't here for the past like 2 hours when we coded the last video. So Tony's he's a little rusty. That's okay though. It's basically going to look very similar to this, but we're creating a route for login instead of sign up. Tracking?
Mm-hmm.
Cool.
Mm-hmm. Mm-hmm.
Okay. Give it a try.
All right.
So, yeah, so notice how up here there's no dot slash, it's just the name of the route, and then you have your request handler. So it's going to be very similar.
Post.
The route we want is /login.
Okay.
Yeah. Great. And then after the quotes, do a comma, and we're going to define our request handler. So that's after the quote, that's going to be an arrow function. So parentheses, and before the arrow function, we need parentheses that takes in rec, res, and next. Awesome. Question from Rohit: which one is better? Jots, cookies, or sessions? So typically cookies are used in conjunction with sessions, and you probably could use Jots with sessions, but one of the features of tokens is that they're stateless, meaning the server validates them every time, and there is no need to keep a session. I won't say one is better than the other. There are different use cases for both, and there actually is a lot of criticism from people that prefer sessions, criticism of using JSON Web Tokens. I like using them. I build RESTful stateless APIs that don't require sessions, so they work for me. And I typically build decoupled applications where the client and the server are running on two different servers. So if you're doing something like sessions with cookies, then you have to implement cross-origin cookies, or you have to make sure that both your client and your server are set up on the same subdomain. It's just a bit more work. And Tony Edgars says, we're all tired, so you're good to go and forgive. Awesome. Okay, so we have our login route. Great. For now, let's just respond with an object. So let's do res.json.
Okay. Res.json.
Mm-hmm. Pass in an object. No! Ugh, my lights went out. The object should have a message property that says an emoji or something. I don't know. Be right back. Yeah, I guess you can't emoji without me, can you?
Oh, I'm looking up an appropriate emoji.
What's it going to be? Oh, actually, I think it should be a lock that is unlocked because you're logging in, right?
Or a key? No, not a key.
You'd be sending the key to unlock the lock. It's gonna go like we're gonna get rid of this eventually, but
Yeah.
it's just fun for now. Oh, not that one. I want the unlocked lock. Okay, cool. So when a post request comes into our server on auth/login, we're just going to respond with this object with an unlocked lock. So let's test this out from Postman. So before, we were making a post request to auth/signup. Now it's going to be very similar, but we're going to be making a post request against auth/login. The body of the request is going to be JSON, and basically we're going to be sending the information for logging in. But you know what I just thought of? I don't remember any of the passwords that we used when we created all of those users earlier.
Can't we just make up a new one?
Yeah, we could create a new user. We could also, for now, we'll just send like Mr. Tony, and I think maybe we set it to like 12345678990.
I think so.
Okay. But basically, the post request to log in has to include the username and password, so that way we can validate it and then log in the user. So let's try password. Cool. So Tony, when I click send, what should we get back here in Postman?
Like our little emoji.
Yes, so we should get because we're basically saying when you make a post request to this URL, just send back an object. So there we go, we get back an object, cool.
All right, wrap it up, boys. We're done here.
You don't get, oh wait, what's the word? You're not off the hook that easy, Tony. One step at a time.
I know.
Okay, so we have made the request. Now, I guess I don't have it here, but let's just like validate the user that they're sending us. It's going to be the exact same logic as when they're signing up, but we just want to do this before attempting to even look them up in the database. So we can see here, we validate rec.body, and if there was no error, then we start doing the thing. We're going to do exactly the same thing. So like validate it. If there was no error, then we'll do the process of like searching for them, which in this case, for now, we're just like returning an object. Else, we'll do this, unprocessable entity. And in this case, and instead of doing result.error, oh no, what just happened? Oh, I like went into that file. Instead of doing result.error, I want to create a new error. And earlier someone mentioned in the chat, you don't want to be specific about like what the error is when someone is trying to log in, because they could be like attempting a lot of different things and like getting hints as to like what they got wrong. If it's like a person trying to like break into the website. So for login, whenever an error happens, we're just going to say unable to log in. Like we're not going to say the username was invalid, the password was invalid. We're just going to say we cannot log you in. Sound good, Tony?
Sounds good.
Cool. So when they attempt to log in, we're going to validate what they're sending us, just like before. So if they try to log in with like, let's say like a blank username, what should we see?
You should see the error that says username can't be blank or must have 2 characters.
Nope. How did we write our logic? Because this is
unable to log in.
Right. So this case, it just says unable to log in. Right now we are showing the stack trace. When we deploy, we won't show that either. But right now, we're not even giving them any hints. So like they're trying to log in, it's like, oh, nope, can't do it, sorry. That's really just to prevent people from like trying a bunch of times and trying to basically like guess passwords. And if we gave them the hint that like your password is invalid, they know that that user exists, okay. Cool. So if they send valid information, we're now responding with an object, but now we want to do this logic. So the first thing is to check if the username is in the database. So before, we actually did a very similar thing, right? We did users.find1. Mm-hmm. We're passing in username and then the username from the body. And then we have some logic in there. So let's do a similar thing. We're gonna get rid of this for now. So users is our connection to the database, to the users collection. So let's do this, users.find1. We're going to pass in an object with the username property. And the value is coming from the body of the request. What is it?
Oh.
Close. So rec is the incoming request.
Mm-hmm.
Body is the stuff that they're sending us. And then what property on that body do we want to pass in here? Username, right. And so In this case, rec.body represents the thing that's being sent to the server. So that's the whole thing. And then we're taking the username that they sent us and trying to find a user in the database with that username. Okay, so then we should get back a user. And this is where we have some logic. So check if the username is in the database. So now it's kind of like the reverse logic from signing up, right? Before, if the user existed, we returned an error that was like, hey, there already is a user with this username. You can't log in with this. Now it's kind of like the reverse logic. If the user existed, now we need to compare their hash password. If the user doesn't exist, then we need to return an error. So let's just do some logic. So say if user, wait, sorry. Do you have control? There you go.
Okay.
If user, then create a body for the if statement. No need to compare it to anything. Basically, if user is a thing, curly braces outside the parentheses, there. If user is a thing, then that means found the user in the DB. So this username actually exists. And then now we compare the password. Cool. Else, if user doesn't exist, what does that mean, Tony?
It means return error.
But why are we returning an error? Like, what does it mean that the user did not exist?
Username not found.
Right. So, like, they tried to log in with something with a username that's not even in our database.
Mm-hmm.
So, very similarly, let's set a status code. We can look up the status code for now. Let's just do the same 422. So do res.status 422. And actually, we're going to return exactly the same error, because as I was mentioning earlier, we don't want to be specific about why they couldn't log in. So yeah, const error equals new error, unable to log in. Yep, and then we just pass the error into the next function. Awesome. Let's be consistent and put a period there. But now, if we try to log in with someone that doesn't exist, what should we see?
Unable to log in.
Yes. So we're sending it basically a user that doesn't exist in our database. Otherwise, for now, let's just res.json that nice little emoji again. Lock. So if the user was in the so this user isn't in the database, but if we send it a username with a user that is in the database, we should get back the lock. Cool. So one step at a time, we're getting closer. So check if the username is in the database. We're doing that. Compare the password with the hashed password in the database. So for this is where we'll use bcrypt. And let's take a look at the bcrypt docs, because there is a function we can use called compare hash, I believe. bcrypt.js. Gonna search for compare. Cool. So we're basically going to do it this style, because we can do it promise. So we do bcrypt.compare. We send in the password that they sent us, right? This is the password that they would have entered into the form. And then hash will be the hash that's inside of the database. And if it worked, like if res is true, then that means that they sent us the correct password. If it was false, then they sent us the wrong password. So let's do it. So right here, we're going to do bcrypt. And I guess before you start typing, we already have bcrypt in this file because we were using it earlier to hash the password here. So that line 38 is hashing the password. And so now here, we want to do bcrypt dot compare. Invoke it. We're going to pass in, okay, what is the non-hashed, where is the non-hashed password that we want to compare?
It's in the local thing.
Not the local thing. So this is coming from what we're sending to the server, right? So take a quick stretch.
So you're talking about like it's coming from the rec body?
Exactly. So this is the password that the client is sending us, and that's what we're going to compare against the hash. And I'm making really big motions with my hands so that my lights don't turn out. Okay, okay, so right there is where, yeah, rec.body.
Password.
Great. And then where is the hash password that we're going to compare it against?
It's in the hash.
Oh, where is the hash?
Let's go find it. Let's go up here.
Well, it's
It's in the bcrypt.
Nope. You have, like in, like right here, you have access to it. There's a variable that has the hash password inside of it.
Is it just password?
No.
I don't remember what it is.
So if you think about this code, we just searched the database for a user that has the username that they're sending us, right?
Yeah, okay.
And what are we storing in the database?
We're storing an ID, a username, and password.
But right, it's the hashed password, right?
Right. So it's not called password.
It's what? User
dot password.
Right, because user is the thing that we just got back from the database. So user dot password will be like a hashed password.
Okay.
Cool. And then we'll do a dot then on that. And let's look at their docs really quick. This just says result. Yeah, so put the word result in there and then give it an arrow function. Whoa, way too many parentheses. Actually, let me close this. Cool. Let's call it result, because res would conflict with our response variable. Resus? So arrow function. Cool. And then for now, let's just res.json an object with result inside of it. Cool. Resus? I don't know. I'm going to just format it this way so it's all on the same line. Cool. And I'm actually going to add a console log right here so we can see what's happening. So we'll say comparing rec.body.password with the hash user.password. I'll definitely remove this log after we see it happen, but this is just to show like what's happening here. So we have the logs up. Let's try it. So when I click send, walk me through what's going to happen, Tony. Like what's happening in our code here?
So basically, we're going to be taking the password we're getting, and we're going to be making sure that it matches the hash that's stored in the database.
Right.
And if we get any sort of errors, we'll get an appropriate error message, basically the kind of generic one that says unable to log in.
Right. And before that, we're literally finding that user in the database so that we have their hashed password to compare it against. Mm-hmm. But let's see, this result should tell us whether or not we're sending it the right password, but we'll send it, result false. So we are actually sending it the wrong password. But you can see we're saying comparing 1, 2, 3, 4, 5, 6, 7, 8, 9 with the hash that. And if someone, technically we could go and watch the part 1 video.
No, let's just pick a new person.
We could Yeah, so here's one thing I'll do. Actually, let's do this. Let's actually remove Mr. Tony from the database, so that way we can sign him up again and give him a password that we actually know.
Let's do Lord Tony. Like,
Okay.
let's just make Lord Tony as a thing now.
Cool. So we're going to sign up Lord Tony. I'll give you the honors. Specify the password. Make sure you use the password that you use on all the banking websites you use.
Yeah, I'm gonna put my social security number and my PIN number, everything.
Cool.
All right.
So
Password
username.
will be you filthy peasants.
Is that at least 10 characters long?
Yeah, and then give it a smiley face.
Okay. So if give me the mouse. We're sending this data to sign up because we're going to be creating this user. Actually, we should use the UI for this, right?
Mm-hmm.
Yeah, let's use the UI. I'm going to get rid of that. Don't save. Okay, so I think we still have the UI running on localhost 8080. Okay, so please sign up as Lord Tony.
Sign up.
Clicking in.
Sign up. There we go. Lord Tony. Yeah. So like at the hospital, my fancy voices are a big hit in some rooms.
Oh, okay. Is that with like the patient that's gone under, or with your coworkers?
Yeah, with my coworkers. I don't do that in front of the patients.
Okay.
Because the filthy has.
Make sure you type it right, Tony.
I know. I can barely type it right the first time. The filthy peasants. No smiley face. The filthy peasants. Okay, cool.
Click sign up. See what happens.
Nom 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 nom. Good.
Okay, so you typed it right. Okay, so now Lord Tony exists, so we can attempt to log in as Lord Tony. So let's update the data that we're sending to try the login.
All right.
I'm just gonna read some messages in the chat real quick. Yeah, Rogue is asking a question. I have no idea. Combining multiple disk images? No idea. Green Coder, thanks for letting people know to hit the like button. And yes, Alka, the result, Reresus, very similar to that. And hey, Matt, welcome. I believe you're the person from Twitter. Hello, hello. And James, hello. Welcome to the stream. Okay, Tony. And actually, can I clear this result? No, I can't. But what should we see here when you send this data to the server?
Let me consult my fancy logs. Where's Atom? Yes.
This is VS Code.
we should see the little thing, the little lock.
Well, not the lock, because we're not sending that back.
Oh,
anymore.
we're gonna get our console log that says comparing stuff.
Okay, but line 70, that's actually what we're sending back to the client.
Mm-hmm.
What will result be?
Would it be a code?
No. We can look at the bcrypt docs. Oh no.
Oh, it's gonna be true.
Yeah, it'll be true because why?
Because it exists.
Not because it exists.
It matches.
Yes, because you put in the right password. My light went out. I'll be right back. So apparently making large hand gestures does not prevent the light from going out.
They're not large enough. You need like a stick.
Okay, but yes, so basically, and the reason we had to do this was before we didn't actually know what the password for Mr. Tony was, so the result was false. But now that we're sending the correct password, we should get back true. I'll give you the honors, Tony. Click the send button. Wait. Okay, click the send button.
I'll click it. There it is.
Wait.
Oh no!
Did you make it just filthy peasants instead of you filthy peasants?
I think I did you filthy peasants. Let me try it again. Let me try. I don't have to make another one again. Wait. Oop. Force of habit, I thought I could press enter and I'd log in.
Oh, geez.
All right, we got to make another one.
Do we? Let me double check that we're using this the correct way. Let's see.
Do we need to do that air right there? Air, comma res?
No, because we're not specifying a callback. We're just specifying the promise. So
Okay.
I don't think we need to hash it beforehand. I believe.
It's like auto hashed.
Yeah, auto gen assault and okay. Oh, actually, okay. So we actually do. So yeah. So we need to pass in the number of rounds so that it hashes it. Wait. We might actually have to generate the hash, then pass in the hash to compare it against. I really thought you could pass it in without hashing it first. Okay. Let's try one more time, but with like a very simple password. And if that doesn't work, then we know that we actually have to hash the password first.
Okay.
Okay, so let's sign up a new user. What shall it be?
Shall be simple man.
Okay, let's just make the password 1 2 3 4 5 6 7 8 9 0 so we can remember it. All right, sign up. Okay, so that sign up worked. Now let's try to log in with that simple man. Ha!
All right,
You typed the password wrong, Tony.
You know what? I think when I created the password, I spelt it incorrectly, but I did it both times.
You spelled it wrong twice. Okay.
This has happened to me like every time I made a password.
Okay, yeah, and Edgar is confirmed in the chat. Like this is how you do it. So, when you're using bcrypt compare, the thing on the left-hand side is not hashed. The thing on the right-hand side is hashed, and this function will hash the thing on the left-hand side and make sure that it was, make sure the result was. Make sure that the hashed password was generated using the same input as this password that they just sent us. Great. Okay, so because we got back true, that means that we actually sent it the right password. So Tony, what would happen if I did this and click send? What should we get back?
You should get false.
Right, because we're sending it the wrong password. Cool. So now we should actually check that. So compare the password with the hash password in the database. Great. But now we need to say, like, what do you think, Tony? So, like, if the result is true, then we're actually going to log them in. But if it's false, we need to respond with an error, right? Because that means they sent us the wrong password.
So we should just throw them. Are you saying, like, what should we tell them?
Oh, what code should we write?
422.
Well, we need like an if statement, right? Let me get rid of this console log. But yeah, but we need an if statement to make sure that
So if result equals false, res dot status 422.
Yeah, something like I'll help you out. So if really I'll just do if result, then they sent us the right password. Else they didn't send us the right password. So
res status 422.
Yeah, we can do this exact same, just send back an error, unable to log in. All right, let's try it. So we're sending the wrong password. What should we see?
422 error.
Unable to log in. Yeah, unable to log in. Great. But if we send it the right password, result true. Cool.
Mm-hmm.
We could definitely clean this up. Like, notice this is duplicate code, right? It's exactly the same every time.
Mm-hmm.
This is a great use case for like extracting this into a function and then just calling that function instead of duplicating this code.
Yeah,
I think
so
Let's
We
do
can
that.
make the function be code 422.
Let's do it. All right, create a function.
Function.
Let's call this like respond 422. Respond error 422. Okay. And so when we create this function, we are going to need two things from this function. Let's take a quick stretch. Res is one thing we need in here, and then also next is another thing that we need, right? So for this function, we need two parameters, res and next.
Okay.
So do res comma next. Cool. And now we can just take this code and put it in there, but we can call our code. So let's do respond error 422, res and next. And we'll throw that in here. And basically now, instead of duplicating that code, we can just call this function several times. Cool. And really, we could also do that. Well, no, we do want to give them the error here because that's when they're signing up. But now if we send the wrong password, unable to log in, so it's still working, but now we've extracted that into a function, so we don't have to write the code multiple times. Great. Alka's asking, did you add a smiley face whenever you signed up earlier with Lord Tony?
I think the first time. I don't remember exactly.
Okay. Yeah, Daston was mentioning the compare function takes the plain text. And Andre in the chat has a good question. How can you prevent forced password? And I think what you might mean by that is like brute forcing, like a user just sending in tons and tons of requests until they get the right password. Right now, we're not protecting against that. So like a user could literally send as many requests as they want until they finally got the right password. That's known as brute forcing. There are packages you can use to essentially rate limit requests coming into your app. Does that make sense, Tony? Like,
yeah.
right now the way we've written this is like someone could literally just try. Okay, let's try 1. Is that the right password? No. Let's try 1 2. Is that the right password? No. Let's try 1 2 3. Is that the right password? No. Let's try 1 2 3 4. Is that the right password? No. So like they could literally, and they could write a script that does this, right? It could just send these things over and over until finally they guess the right thing, and then boom, they're in. You know. I don't have it in our checklist to check for this, but as an exercise for the implementer or reader, look into rate limiting. And there is NPM packages for rate limiting. You can search for like rate limiting express. Express rate limit is 1. And basically you can specify how many requests per second they're allowed to make to your server. And if they try to make more than that, it will actually just block them and respond with an error. Interesting. Yeah, there are other packages that will also store things like the requests coming in into a database. So it will actually keep track of like what IP address made a specific request, and then respond with an error if that IP address has made many requests. Hey Greg, welcome to the stream. Hello, hello. Okay, we aren't going to cover that here. I think we might actually try to add something like this in the next episode. Because that would be a good security feature to add. But for now, let's create a token. So right now, we're just responding with, yes, that was the right password, good job. But what we actually want to do is respond with a token that uniquely represents that user, that in the future they can send to the server, and then we can verify that they are actually logged in. So For that, we're going to be using Json Web Tokens. The package we're going to be using for this is called Json Web Token. And this allows us to create tokens. So just a quick note on like what JSON Web Tokens are. It's basically a way of a server generating a token and then later validating that it was the thing or the server that generated that token. A JSON Web Token actually has data encoded inside of it, so we're actually going to put like the username and ID inside of this token. And that way, on subsequent requests, like if we're trying to make a request where we're making sure that the user actually is logged in, they're going to send this token with their request, and we actually have server-side code that will validate that token. Cool. So JSON Web Tokens is a standard, and essentially it creates a thing that looks like this. It's split up into 3 parts. You have the algorithm that was used to generate it, you have the actual payload, and then you have the signature, and this is how a server can verify that it was the one that generated a specific token. This will make a little bit more sense as we actually start to implement it. So first, let's install JSON Web Token. So do an npm install of JSON Web Token. Cool. So we have the package. We can check out npm. It has, so typically there are 2 methods you use. The first one is sign. So this is going to be the thing that generates the token, and that's what we'll do whenever they're logging in. And then later on, when we're authenticating a request, we're going to use verify. And verify is the function we use to make sure that we were the server that generated that token, and we can actually trust that token. So let's do it. We can see an example here. Just a second. Cool. And so basically, after we have verified that they sent us the right password, this is when we actually want to generate the token. So at the top of this file, let's bring in JSON Web Token. Let's go ahead and require it in. Yeah, and Simjon in the chat asks, what's the difference between npm install and npm install -- save? In the latest version of npm, if you leave off -- save, it actually does it by default. So when you do an npm install, it actually saves it to your package JSON. So there is that package that we just installed. Great. Cool. And Andre in the chat does have a suggestion. Do a token associated with the user and limit it. Like technically we could, every time they attempt to log in with this given username, we could actually store something in the database that says like an attempt was made to log in with this username. And then if they got the password wrong, like increase a count or something and then have a check against that count. We won't do that now, but it definitely is something we can do in the future. We'll probably do it in the next episode. We have been streaming for 3 hours now, so this is something we'll do probably next week. After we generate the token, I think we're going to call it there. Awesome. So this is where we're actually going to sign the token. So the idea of signing is your JSON Web Token has like a payload inside of it. You'll notice in this case, the payload is just like the name, but our payload is actually going to be like the user information. So like username and ID. And that way on subsequent requests, we can actually check to see and get access to the username and the ID of the logged in user. So let's do just that. And so let's actually call this JWT so it's a little bit easier to use. And then before we use it in this method, we're going to basically create the payload that we're going to sign. So let's just create an object called user. Do const user equals, and really we just want to grab the ID and username from the user that we got back from the database. So we're going to say ID is, well, and actually we're shadowing this user with a new user. Let's just call this payload. And ID is going to be user._ID. Underscore ID.
Why are we doing underscore exactly? Is that just because that's the way it's being stored?
Yeah, so in Mongo, when you insert rows, and we can see in the database, it actually stores it as underscore ID. That's a Mongo thing. Okay, and then we'll also send back the username. So do username, colon, and that's going to be user.username. Great. Okay, so this is the payload that's going to be inside of our JSON Web Token. And now we want to sign it. So in their docs, you see we can do jwt.sign. So let's do that, jwt.sign. And then we'll pass in payload as the first parameter. The second parameter is the secret that we use to sign it. So this is the thing that we actually use to verify that we were the ones to create this token. And this typically is defined like in an environment variable. So we don't have an env yet. Let's go ahead and create one. So in our server folder, I'm going to create a file called .env. Inside of here, I'm going to call this token secret. And then we're just going to set that equal to something really long and hard to guess. Actually, I thought I had a command installed to like generate a really long thing. Actually, Tony, I'll give you the honors. Just mash on your keyboard for like 5 seconds. Okay, you can stop now. This is fairly unpredictable. However, there does seem to be some patterns in the keys that you've pressed. Regardless, this should just be something really long and really hard to guess. A lot of tutorials you see online actually set this to keyboard cat, but then they never change it when they actually deploy their app. So it's important to make this something really long and really hard to guess, because if we can guess this secret, we can generate fake tokens, meaning we could generate a valid token and not have to know a password for someone, and that's a bad thing. So our token secret is being big and long and hard to guess. Oh, just a second. And then let's see, do I have .env? We don't. So to bring this .env into my app, we're going to install a package called .env. So do an npm install of .env. No. Okay, I'll be right back. Cool. So we installed that package, which pulls in this env file whenever we're like in local development. When we're deployed on a server, we're actually going to have these environment variables set. But we have that, and then in our main file, we're going to require it in. So just right here, do a require of .env. So you don't need to set it to a variable, just do require. Invoke it. Oh, evoke, pass in the string env. Sorry, .env, so the name of the package. DOTENV. Without the dot. Cool. And on the end of that, do .config. So this will, when we're running locally, read in all of the environment variables we have defined in this .env file, and then we'll have access to them. So over here, when we pass in the secret, we'll do process.env, no dots, so just process.env dot all caps token underscore secret. Cool. So this is the secret we're going to be using to sign the payload. Let's take a quick stretch. And then we'll also pass in, like, when will this JSON Web Token expire? We can see from their docs there are different ways to set it. You can do expires in 1 hour. I typically like to set it to like 1 day. And basically, after that amount of time, this token is no longer valid. So if they tried to use it on our website, we would basically redirect them to the login page because the token has timed out. And it's always good to set an expiration, because if somehow the token gets compromised, like someone gets a hold of your token somehow, it's eventually going to be expired, so they can't use it anymore. There are different ways to specify it. We're just going to do 1D. So we can say expires in, and the value will just be 1D. Great. And then lastly, we specify our callback. And the callback, well, let's look at some examples. Gets access if there was an error signing it, and then it gives us the token itself. So our third parameter here is going to be a function. So let's do an arrow function that has 2 parameters. So make sure you do parentheses, and we'll do so ERR and token. Cool. And in the body of this function, we're actually going to respond with the token. So whoa, sorry. If there was an error, we probably should respond with the error 422. Basically, like, we couldn't create the token. Otherwise, we're just going to respond with the token. So let's just say if error, and then inside of this if statement, so curly braces on the outside of the if. Tony is getting real tired. Okay.
Oh, okay. Sorry.
In here, we'll just use our same method. So do respond to error 422. And pass in res and next. Cool. So if there was an error signing the payload, something went wrong, we're just going to respond with an error. Otherwise, we can actually respond with the token. And this is it, Tony. We've made it here. So do a res.json, pass in an object, and put the token inside of it. Just token, just lowercase token. Cool. So if the user sent us valid information, the correct username and the correct password, we then create a token that has their ID and username inside of it that expires in a day, and then we're just going to respond with that token. So in next week's episode, we're going to show how you would store this on the client side and then make like authenticated requests. But let's see it happen. All right, Tony. Do you want to have the honors?
Mm-hmm.
Okay, so when we click that send button, what should happen?
I don't even know. I don't even know.
We're sending it the correct username and the correct password, okay?
Yeah, so she get a token.
Yeah, so we should get the token back. Let's see what happens. Try it. Hey!
Hey!
We got a token, cool. And so we can actually like put this into the JWT website and verify it. So let's check it out. So if we put our token in there, we can see that inside of it we have ID and username. IAT would be issued at, so when it was generated, and then EXP is the expiration time, and in this case it's 1 day from now. But right now it's saying invalid signature. So I think their website is broken because I'm putting like an invalid signature in here and it's actually saying that it's verified. That's just not right. Let's double check that we actually are passing in the token secret. So when a request comes in, I'm just going to say token secret is, pass that in. So we should see, yeah, so this big long thing that's in our .env, and that's what's being used to generate it. Yeah, this shouldn't say signature verified. I've had this issue in the past. Next week when we implement like verifying the token, we'll see that the library like won't verify it unless it was generated using this token here, this that secret there, and that's the key thing that actually makes this work. Like, we can verify that we were the server that actually generated this token because we're the only server that has access to this secret token. If someone were able to guess this, they could generate fake tokens all day, but that's the main key here. Oliver is asking, where are the unit tests? This is a Newb series. I haven't even done like an intro to unit tests. Tony, do you know what a unit test is?
When you test the units, son. I'm assuming it's some sort of security test.
Not security, no, it's just general code tests. But in the future, definitely. Andre is mentioning JavaScript is not for the backend. Then you probably shouldn't be watching any of the videos on my channel because I use Node for the backend all the time. Oliver is saying, set the token on the right and then repaste the token on the left. Oh, no. Oh, I see. As you type here, it's setting the token. Or setting the, yeah, it shouldn't do that. It hasn't done that in the past. Okay, so, okay, good call. We can make this work. Oh, here it is. So this is what the thing should be. Yeah, that's broken. That should not be updating as I type it. But here's the thing. If we put in the actual token secret here, and then we have the, like we just put this whole paste this whole token again, it should say verified. And it does. Because this token that I just pasted in was generated using this same token that I same secret that I pasted in here. Okay. Yeah, I don't like, and Oliver's mentioning it. I feel like this tool didn't used to do that because it used to be like the token remains the same on the left, And then the signature that you're typing in here basically will just say invalid signature, and it shouldn't be changing this. I don't know why they changed it to do that. Okay, because that confused me in a previous episode. I think it was in the, might have been in one of the Trello clone videos that I did. The tokens were just this. It was getting this exact error. What? Nosebleed?
Yeah, like just massive brain hemorrhage.
Okay, yeah, we're done though, Tony. We have been streaming. We've been streaming for like, wait, did we stream? We're going for 2 hours, I think. Before 2.5. We're going for an hour now, but let's look at our checklist. We created and signed the JSON Web Token, and then we responded with the JSON Web Token. Awesome. So next time, we'll actually create a login form where the user will send their information. We'll like validate it on the front end, and then when they're logged in, we'll actually store that token in the browser so it can be used in subsequent requests.
We should make a secret login area. Like when you get to a login thing, you get like a video or like a GIF of like keyboard cat or something. But you can't access it without signing in.
No, we can. I think that's a great example use case. So, and we can do that next time. So, unless like if you try to go to that page and you're not logged in, you just get redirected back to the login page. But if you are logged in, you can access the secret GIF.
Yeah.
With a soft G. All right, Tony. Any last comments or questions about this stuff before we end it?
Last comment is Saturdays are for the boys.
I don't know the reference, but cool.
It's just an internet thing.
Okay.
But yeah, I got nothing. I think that was kind of it. Like the token thing, I think we could probably maybe next time, like we can kind of start off with like a recap on like what tokens are.
Yeah, because this is definitely like one of the hardest parts about all of this. Like for one, like what does it even mean to be logged in, right? Like
right, because like the whole idea of like secrets and tokens and all this stuff. It's sort of like in my own personal like readings about authentication. It's just kind of stuff that like I'll figure that out eventually, and it's like okay, well now that we're actually doing something like that, I'm kind of like, yeah, like I couldn't explain to you necessarily what's 100% happening in terms of like get and post requests, because in my normal, I understand how like you make a get and post request, but like the idea that you're technically like logged in is still weird to me.
Hopefully, in the next episode, we can demystify all of that.
Yeah. It's like your chat's popping off right now about JavaScript of the backend. What's going on, guys?
I'm gonna mostly ignore that. If anyone does have any questions, I'll definitely answer those before we end. Tony, do you have to go?
I don't have to go like immediately if you want.
You could have said yes and just left, Tony. You didn't have to say that.
I gotta go. My house is actually I went outside this morning and there was like something on fire in the distance, and I was just like, that's not my problem.
Like a house was on fire?
I don't know. Like I don't know if like I'm in an area where they do like bonfires or something. I don't think so, but like it looked like something was on fire.
Okay. I will also I'll send a message with this code. It's in the description, but you can click it and go check it out. Who is Tom is saying, awesome, wanted you to do such a session, and now you're doing it. Thanks, you're very welcome. So this is the third part. There's probably going to be like maybe 2 or 3 more parts.
Oh, God.
It's pretty much never ending, and I definitely want to have like a video dedicated to just like the security of it all, like of all the things that we coded. What do you want to make sure that you did? What do you want to double check? And typically, if you're actually building this yourself, you probably shouldn't. Like there are existing solutions. You could use like OAuth with the third-party provider. this whole series is really to demystify like what's happening, because we use the web all the time, we use apps all the time, we log in all the time, but like, do we really know what's happening?
What are you actually doing when you do those things?
Right.
Yeah, I would love to see that explained in like some really funny webcomic. I think anybody who's in the Discord, we need a comics page or channel for explaining basic web things.
Wait, say that again?
Like, so you know how there's like all those comics and memes and stuff? I think we need a meme page in the Discord.
Oh, we have like a random channel.
Yeah, I think yeah, we need to rename that bad boy.
Yeah. Edgar says, nice stream. I wish I had this when I was learning about Auth and Node in general. So those who are new to this are so lucky. I guess so. I hope so. Oliver's asking, are you going to send the token on a header? Yes, but in the next episode. Like right now, don't do that. Right now, we have the route that sends back the token, but we haven't actually created a front end that will get that token, store it, and then in subsequent requests include it in the header. But yes, next time.
Okay, yeah.
that was a lot, Tony. I'm exhausted too. Like I took some caffeine before the second, but my brain's getting foggy as well.
I preemptively, like, I had like 2 Red Bulls before we started this, and I was like, all right, all downhill from here, baby. Here we go.
Awesome. All right, I think I'm gonna end it there. Thanks so much, everyone for tuning in. Thanks. Actually, let me pull up the donations that happened. I do want to thank everyone that donated. Doo-doo-doo-doo. It's happening.
Can we begin and end the streams for Newbie Tuesday with the NFL theme?
I don't want to copyright violation.
Is that copyright infringement?
I mean, we could like hum it or whistle it.
Like, do it on my kazoo?
Okay. Shout out to Josh Jones for the for the $1 donation at the beginning of the stream. Really appreciate it. Wait, Tony, that hurt my ears. I'm sure it hurt people that were listening at home too.
I'm sorry.
Yeah, don't do that, please. Rodrigo, you're very welcome. GG. Yeah, so everyone should just spam the chat with GG right now. Porcupine says, cheers, Tony. Tony, you are a machine.
Yeah, now, how good of a machine, that's up for debate.
Yeah, I don't know. I mean, this is a lot to take in, especially being new to this, being new to code, being new to the backend. Can everyone that's watching live right now just say GG and hit enter in the chat, please?
Press F to pay respects, boys.
So if you guys ever watch the what do you call it, the Bob Ross stream on Twitch, it's hilarious because like he'll finish a painting and it's obviously not live because it was filmed like in the 70s, 80s, but everyone's just like GG Bob. All right, thanks everyone for tuning in. Thank you, Tony, so much for sticking through it. Tune in next Saturday for part 4, where we will actually implement the client side of signing up, of logging in and have like a protected page. It's gonna be great, you don't wanna miss it. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. And here's this.